Let's make it more curvier. Oh hey, hello, what's happening guys? Welcome back to our channel. I'm Pixar and today we're gonna learn about things get curvier. I mean waves. So let's get started. So let's start with our chapter waves. It is a part of atomic structure. To understand atomic structure briefly, we need to learn waves. A wave characteristics. Characteristic of waves. A wave is characterized by wavelength, frequency, velocity, wave number, and amplitude. So, what is wavelength? So, guys, wavelength is nothing else but the distance between one crest to another crest. Means you guys see here, it's a wave. It is one top to another top. The distance is wavelength. It is also the same as the distance of two bottom, and we write wavelength as lambda, like here we saw in. And the unit of wavelength is very quite simple to guess. If you guess it, it's correct. It's meter, centimeter, or millimeter, or Armstrong, etc. Because it is a length. If you guys don't know 1 Armstrong distance is 10 to the power minus 10 meter. So let's move on to the frequency. Frequency is denoted by nu. It is right like abhi, a curvy V with its right side curved to upwards and left side curved to downwards. A frequency is nothing else but like if I draw a line, it's nothing else but like two lines from here to here and bends these half waves and these half waves to form a circle, then this is a frequency. I'll draw a line and passes a frequency between them. The number of circles or number of waves passed through it is known as frequency. A frequency is denoted with nu. A frequency is denoted with nu, and the unit of frequency is hertz. Hertz. Thus, 1 hertz is equal to 1 cycle per second or 1 second inverse. Velocity. It is the distance traveled by waves in 1 second, such that c or velocity is equal to distance by time in second. Generally, we take velocity. Generally, we take velocity of light or waves is as taken as 3 into 10 to the power 8 meter per second square. You can see here, so I write down here 3 times 10 to the power 8 meter per second square. Sorry, meter per second. Wave number. Wave number is denoted as nu bar. Nu and a and a line in the top of the nu. So what is wave number? Let's see. It is the number of waves present in 1 centimeter of or or wave number may be defined as the reciprocal of the wavelength, means nu bar is equal to 1 by lambda. Its units its units are also quite simple. The inverse of unit of lambda means meter inverse, centimeter inverse, etc. Amplitude. It is the height of the crest or the depth of the throw from mean position. From mean position. If you guys don't know what is amplitude, then I will draw a graph. Then I will draw a graph to demonstrate you. If it is a wave, then this is and this is our amplitude. There is a relation between lambda, nu, and c. The relation is nu is equal to c by lambda. You can guys take a screenshot of this equation and its types or relations of another equations. Take a screenshot if you want. Then we move on to the next part, electromagnetic spectrum. When sunlight is passed through a prism, it breaks up into 7 different colors like deep, deep violet, indigo, black, blue, green, yellow, orange, and red. Thus, the splitting of the light is constituted of radiating is called dispersion, and the pattern of the radiation obtained due to dispersion due to dispersion is called spectrum. The instrument in which the spectrum is recorded is called spectrometer or spectrograph. Beside these 7 colors, so many radiation are also formed. If we arrange radiation by its increasing order of wavelength or decreasing order of frequency, then the arrangement is called electromagnetic spectrum, which is given below. So you guys see here, it is cosmic ray on the highest frequency, then gamma rays is lesser than cosmic rays, then X rays, then UV rays, ultraviolet rays, then big gear, the visible radiation, which is situated between 318 nanometer to 760 nanometer of pre, of wavelength. IR radiation, microwaves, and radio waves. And the radio waves are the highest wavelength, and the least wavelength is cosmic rays. You can guys take a screenshot if you want. Then we move on to the solar spectrum. When sunlight is passed through a prism, then different spectrum were formed. As these spectrum were emitted from the sunlight, so these are called solar spectrum. Solar spectrum is continuous in nature because the second color started before the end and the third before the end of second and so on. So if you guys see a rainbow, then you cannot see all 7 colors with your naked eyes because second start in the half of the first and the third in the half of the second, means You can guys literally no, don't or cannot see 7 colors. Then we move on to the next, atomic spectrum. When atom gain energy, it il- its electron gain energy. Thus, the electron promoted to the higher cell, but higher cell are unstable, so they have to come back to the lower cell again. During this transition, some amount of energy released. If this energy appears in the form of light, then we get light. If this light is analyzed by means of prism, then the spectrum form is called atomic spectrum, as these spectrum are formed from the excitation of atoms. In the in the case of atomic spectrum, a black band appears in between two colors. So atomic spectrum is discontinuous in nature, such that we can count all the colors formed. Again, atomic spectrum is classified into two types: emission spectrum and absorption spectrum. So guys, let's start with emission spectrum. Emission spectrum. These are the these are produced by analyzing the radiation emitted by exciting atom. These atoms can be excited by heating the substance very strongly, by passing the electric current through the gas, by passing electric current through the filament. When radiation emitted by the exciting atom the pass through a prism, then the discontinuous spectra for the spread separated by dark lines. These are called emission spectrum. Emission spectrum are also called line spectrum. Line spectrum is the fingerprint of the atom because differences produce completely different from the line spectrum. Means guys, emission spectrum is nothing else than the atomic spectrum which is given as the properties of the atomic spectrum, because atomic spectrum shows the band of black lines which separated the colors, and you can also count. It is also the fingerprint of emission spectrum. Now move on to the absorption spectrum. When light emitted from the excited atom, it passes through a solution or gas and then through a prism, which only dark bands appear because all the color absorbed in the solution or gas. Thus, the spectrum is the absorption spectrum. Take a look, guys. Here we have bulb. It's emitting light. If we pass through a slit, a tiny slit, but you can guys see here it is bigger, but a tiny slit, and then it passes through a solution or gas. We take here a solution example. Then it passes to the prism. Then it's appear with only black lines on the board. So guys, that's it for today. I will leave some questions about frequency and wavelength, and I will leave some frequency, wavelength and velocity questions in last. You can take screenshot and practice them. In next class we will read about Planck's quantum theory. That will be such a interesting topic. So that is it for today, guys. Hope you enjoy. Like, comment and share this video and subscribe to our channel. Till then, take care.